right arm. Freeze left arm. Or relax left arm. Relax left arm. Freeze left arm. Record object pose.
Does that mean it didn't
Record
understand?
object pose.
Oh, it found it. That is sick. Found the cup.
So
It's looking at it.
it sees the table, and then it sees something on it. It didn't recognize it, but it put a box around it. So what we'll do is have it maybe pick it up and hand it. Relax right arm. Save pose. Save pose. Close right hand. Save pose. Open right hand. Save pose. Okay, so now if we look here, some of the robot's poses that I saved have arrows to the object, which means they're relative to that object. So if this object moves, those poses are going to move together with the object.
Because otherwise it would just put the hand in the
Put the
exact
hand
spot
at
that
the-
you
at
put
the
it before,
exact-
which wouldn't be the right
yes.
one.
Sorry, just one quick question. I'm excited that you all want to take pictures and videos. You might want to ask, is it okay to post them? Do you have any restrictions on if they
No
want to post to
problem.
Instagram or somewhere else?
No problem, but say good things.
Yeah.
Do you have a tag?
No.
It's going on. It's going on Reddit.
Execute action.
Ah.
Execute action.
Is the cup now at a different spot than before?
It's similar. We'll do a more difficult test.
Cool. You guys had to break the robot.
Execute action.
You don't see it.
Got it.
Nice.
One more.
But, yeah.
Execute action.
No.
Oh, you can't see the cup? Yeah, it's too far.
Oh, it's too far. So because it's this arm, it's not going to reach.
Oh, it can't reach it.
Execute action.
So can you tell them a little about the PR2 and Ross and how you program it?
So PR2 is it's a very expensive robot. PR2 is the type, is the model of this robot. It stands for Personal Robot version 2. So it was built in a company in California, and it's designed mainly for thinking about personal computers. So back in the day, people only had computers at work, and these were for doing very serious tasks. But over time, people started having their personal computers at home, and they started doing different things with it. So the idea is to be able to do that with robots as well. Right now there are robots doing, like in factories, doing like assembling cars, doing things like that. But with personal robots, we would be able to do, you know, how to do household tasks, or maybe help out with, maybe play with children. So it can be a whole bunch of things. So the robot itself is, because we're thinking it's going to be, you know, near people, it's designed to be very safe. So right now, for instance, the arm is actually trying to be at this position, but I can move it away from that position. So it's going to try to go back there, but this sort of means that if there was a person who was already there and the robot tried to go there, it wouldn't push too much. So it has very big springs in its arms that are carrying all the weight of the arm, and those springs you can just counter them. This also makes it safe. It sort of saves it from itself, because a robot, you know, it's trying to go to a position and maybe there's a wall in between, and it keeps trying to go there, it can break itself, right? And then the other thing is when the power is off, so those of you who programmed it, when I say relax arm, it just turns off the power in that arm, and the arm is sort of floating in the air, which means that, you know, if suddenly its battery dies, it wouldn't just fall on somebody. The arms would just float and not really hurt anybody. Otherwise, I think the most expensive parts of the robot, besides the, you know, the arms that are very safe, are the sensors. So the rotating sensor here, it's called a LiDAR. It's a Hokuyo sensor. So there are two of them, and they're pretty expensive. One of them is rotating, the other one is at the base. And that one is to make sure when the robot is moving around, it doesn't run into anybody. So it always has that constant information, because its base is usually what goes first. What else? ROS. Okay. So the way that we program it is so there's a big project that's international. So people from all over the world are contributing to an open source code for controlling robots. So this was started also again at the company where the robot was built. What happened was before that, so when I started studying robotics, we used to build, so we had a robot, we needed to write our own code for the robot for very simple things like, you know, if the robot is at a certain pose, does its two arms collide with each other? This is called collision checking. So collision checking, you know, you need to do it, and if you have to do it on your own, it's a lot of math problems that you need to solve on your own, a lot of code that you need to write. But for instance, through ROS, for like a standard platform, I don't need to do that, so I can focus on things like how can we make the robot friendly, easy to use, etc. So basically, by making it open source and sharing with everybody, we're sort of advancing together, and the robotics field is moving forward as opposed to one person moving forward on their own with one robot. Anything to add to that?
So and you program in C++ mostly?
Oh,
or
yes.
Python, or?
It's mostly C++ and Python code. So far in my class, so we have a class where students are learning to program the PR2. It's all Python. So you guys learn programming? That's cool. That's great. Which languages?
So far we've got JavaScript and HTML.
Oh, very nice. There, you can actually also do things in a browser with like JavaScript to do